Okay, lesson will be of much interest to you because it says I will use the formula or a TMV solver to determine the values of a present value of an annuity. Now, so a couple different things going on there. We're talking about an annuity, so that's money that happens more than once. But this time we're talking about a present value. And this is important because this is the way our world works in regards to borrowing money. So the present value of annuity is the principal that must be invested today to be, to provide regular payments of an annuity. So what's happening is you're putting in a big chunk of money right now, and then in the future you can take so much out of it a little bit at a time in most cases. So that's really what happens when we're talking about borrowing money. So loans are repaid by making equal payments over a fixed period of time. So what's happening is you're not putting money in, but you're borrowing this big hunk of principal, and then over time you're paying it back. Okay. So another example would be trust funds are an example where money is invested and over time a regular withdrawal is made. The payments form an annuity where the present value is the principal that's borrowed at the beginning. Okay, so when all the payments have been made, guess what? The principal and interest due will have been paid. So in other words, the future value will be zero. So that's important for us. So here the future value is going to be zero. Okay, and so that is the main reason why we really study it, because we're talking about borrowing money. And when we borrow money, when we're finished paying it, we want our future value to be zero. So there's two different ways to do it. One is with the present value annuity formula, which is a monster, which is very similar to the other annuity formula. The only real difference is it's really in this bracket here. You can see we have to the power of negative n, and the brackets at the end in the square bracket compared to the beginning. So what these stand for obviously is present value is in dollars. Our R is our regular payment in dollars or withdrawal if we're withdrawing money from it. I is the interest rate per compounding period as a decimal. Okay, so when we use the formula, we have to change the interest rate to a decimal and then divide by our compounding frequency. And N is the total number of compounding periods for the life of the investment. So here's the example we're going to look at. So your long lost uncle sets up an annuity for you. You will be paid $500 at the end of each month for the next 5 years. The first payment will be made 1 month from now. How much must your uncle deposit to provide the annuity if the money earns 5.7% compounded monthly? Okay, so the reason that this is the present value of an annuity is because you're going to be taking out that $500. So let's start with our variables down our side. So we want to know how much our present value that our uncle has to put in for us. We know that the regular payment he wants to give us is $500. We also know that our interest rate per compounding period is, there's the 5.7, so 5.7, oh, sorry, I got used to using that graphing calculator. It's going to be 0.057, and I have to divide it by 12 because it's monthly. And my N is going to be 1 month from now. That just means that the payment happens at the end. And we talked about that a bit, especially with the graphing calculator. 5 years, and it's going to be 12 times a year. So we're looking at the number 60. So I'm going to bring up the formula and make it just a little bit larger for us so we can see what it looks like. And we're going to substitute the numbers into it. So bringing up Oh, let's use blue this time. So we have 500. Again, really important that when we use our graphing, or not our graphing calculator, our scientific calculator, that we actually enter our brackets in as well. Now notice I didn't calculate this 157 divided by 12 because it's quite a little decimal and I didn't want to write down all the decimals. So to me it's just as easy to do it this way. Now remember it has to be to the negative power of 60, and on the bottom again I have to do the 0.057 divided by 12. Now what I'm going to do is I'm going to put a bracket around this so the calculator understands that this has to be divided first before I divide the top part by it. So what I am going to do is I'm going to bring up my graphing calculator just so we can actually do this. Now mine was on the financial mode, so I'm going to get out of it. So I have 500. I'm multiplying it by bracket 1 minus another bracket 1 plus 0.057 divided by my 12 to the power of negative 60, and then I close the top bracket off completely. And I'm dividing it by, and as I said, I'm putting the denominator in a little bracket by itself as well so that I have no concerns as far as order of operations. So that's what I've typed into my calculator, and you can see that my uncle would have to invest 26,000, and I'm just going to take a snapshot of that number so that again when it disappears, so I know that I have blue again. I have $26,050.33. Now I could actually figure out how much my uncle made in interest too. The way we could do that is we're taking $500 out, right? So even though this isn't a question, I have $500 and I'm getting to withdraw 60 of them. So actually what I am taking out is like $30,000. So my long lost uncle actually over time is giving me $30,000. He's investing 26. Okay, so he's making for almost $4,000 in interest, which is pretty great. Now, that's using that formula. Now, just like we did with the other annuities, we can actually use the TMV solver to do the exact same thing. And what we're going to do is we're actually going to show you how to do that. So using the same question, what I need to do is, sorry, if I look at my N, I know that it is 5 times 5 years monthly, so that's 12. So I could either put 60 or that. Here I do not want to change it to a decimal, so it's 5.7%. My present value. Well, I have some stars up here in red, and that's really for quite a good reason, and I think I have it that we have to erase it. My future value this time is going to be 0. Okay, and we talked a little bit about that. Now, the reason it has to be 0 is I do not want any money left over. So it's all going to be given to me. My payment is also going to be a negative number because my uncle is giving me, I'm taking $500 out of the account. My present value is what we're finding, and compounding periods, etc., are both, in this case, 12 because it was monthly. And we're doing at the end. So if I take the graphing calculator, you'll see that in some senses, it is actually a lot easier to use it than the other way. So apps, enter, enter. Okay, so this time I have 60. My interest rate 5.7. Present value I don't know. I'll just leave it like that. I'm taking out $500. In the future, I'll have 0, and my payments and compounding is both the same. So again, I put my cursor over PV, alpha, enter, and amazingly up comes my answer of $26,050.33. So again, we can take capture a picture of that for ourselves. Now, it would be much easier if you could take a picture of your work like that, and I would know exactly if you're doing something correctly or not. So again, I didn't put a therefore statement in the last one, but I really should have because we're talking about a word question. So we'll put it on this one. My uncle needs to invest $26,050.33. Now, let's see, was that the exact same number as before? Well, amazingly, it was. So you can see that either way, either using the formula or the TMV solver, you get this exact same answer. It's just which one causes you the most work. I think the graphing calculator TMV solver is much easier to use. It's faster. It allows you to compare a lot of things. Um, the downside being that most of us do not have one of these just laying around at home when we want to talk about things. However, you can get all of these kind of formatting kind of things, software on the internet, and it's free. So you can do it that way as well. So you have some fun working out some present value of annuity questions.